Okay, so now let us write the program for decoder. Let us continue with that. Now you see here we done always. Okay, that is fine. The inputs we declared A1, A0 must be given the always. Begin if we are using if statement. If input A1 is equal to 0, very important. This is the equivalent operator. Double equal to you have to use. Same like your C++. Then the variable 0 and this is and is this and is conditional and it is not the logical and. You remember because you might have had a doubt. The same ampersand we used for logical and how you can use the same ampersand here also. So when you use in the if statement, that will be a conditional and A0 is equal to 0. So both are 0, 0. If the statement is true, then D naught will be high as per the truth table. Next, if A1 is equal to 0 and A naught is equal to 1. Now, what I'll get? D naught will be high. Correct? D1 will be high. D1 will be high, put a semicolon. Next, if A1 is equal to 1 and A0 is equal to 0, then D2 will be high. Next, if A1 is equal to high, correct? High and A0 is equal to high, both are high. Now what will be? D3 is equal to high actually, semicolon. Now you can place the end actually here. See? Now you can write the end. See, this begin and end is over. Next, always for this. Next, what you have to do after the end, you have to write end module. See, this is the only using if statement. This is only if statement. I hope is it clear for you now. Now what I will do, let me go for the second thing. How we will write actually. So how we will write the second? So this is the one, right? See, this is one module. This is the one model which I wrote. Okay. Next I will write the second model. Here, only if statements. The extra things are same only, okay? Okay, yes. If A1 is equal to 0 and A naught is equal to 0, then what? D0 is equal to 1. Next, what I should do now? This is for if statement I use. Next, if else. I hope it's clear, right? If else I'm going to use. So now what I'm do? Same thing. Just I will write. See here, if all or if only, right? So as I said now, instead of this last statement, I will write here else. See, this is what the additional things I'm using here. See, you might have got that clarity now. Now, if these three conditions are gets failed, automatically come to the else statement because the remaining condition is what? Both are high, the output D3 is equal to high. That is the one. Next, Next is nested if. Correct? Next to go for nested if statement. Yes, so for nested if statement, same. What I will do, I will take the same thing. Example. Let me take this only. Okay. So this is nested if statement. What I will do, now you can see what I will do, nested if statement now. Nested if in the sense, see, simple else if, else. See, if the statement is put is gets failed, it will check like this. Else if, then again else if, then else, then D3. Now you may have the doubt in the syntax. I used, you see here, begin end, but I'm not used begin end here. Yes, you understood? Okay, let me show how to use this begin and now. Now you can see, as you know, the outputs are 4 variables, correct here, totally 4 variables. But here I used only one variable, only one, that is meaning is only one statement I used. Simple example I'll show here, how I will use the begin end. Okay, so let me show how I use the begin end. Same in this only I'll show. Control C. Okay, you see here. See this, what I will do, begin D0, D1 will be what? D1 is 0 actually, correct? Then D2 is equal to 0. This is truth table, just to truth table writing, same truth table only will write. 0, 0, then end. See, this is what I meant. If begin, else if, again end begin. This is what the difference. This is the difference. If I am having more than one line statement, if I am having like this more than one statement, then we have to use the begin. Same like your C program only, equivalent to C program. That is why each and time I am putting this begin is nothing but open, this end is nothing but close brace. Remember that. It will be very, very easy to write. Okay, let me write. Using vector input types. Vector input output type. Okay. Now let me write module followed by decoder 2 to 4. Here what I am going to do, vector. So in the sense, I am not going to specify A0, A1. Instead, I am going to specify A. Next output, I am going to specify D. Then I will close. Semicolon. Next here I will write input. How much the size of your input is 2-bit. So 2-bit, and this is what I should do. Open the square bracket 1:0. Then close the square bracket. You give us A. Semicolon. Yes. Next. Output, how many bit is output? The output is 4-bit actually. So it's supposed to be 3:0. 3:0, the output parameters D. Then D3, D2, D1, D0 will get. Okay, next is over. This is over. What next you have to do? Register, very, very important. Register, you see here, register declaration will be like this. Register 3:0 because it's a vector type output into D. Semicolon. I want to show the syntax for register better, right? Still I'm not shown here. Syntax for register, because earlier we studied wire. You might have understood. Reg name. Semicolon. Reg name or sometime I make semicolon. Yes, okay, fine. This is yes. This is the syntax for register. Reg name. So now register is D. Same the output variable I given here. What next is always at the rate. What is the input is? Input is A actually. The input is A. Yes. So present put. Okay. Now begin. Okay. You have to always after always the begin is must. How it will execute in the sense you see here, let me say instead of this here I will tell here if there is any change in this value a1 or a0, any one is get changes in the input, then this program, this statement will get executed. This is what I meant to say. So only we say this is the sensitivity less, it will sense your input signals. If there is any change in the input signals, then the following statement will get executed. So how many times it get changes, that many times this will get executed. So now here your input signal, you should not give output begin. Okay, after the begin, what I will do? If. Now you see, we given in a vector type. If we given in the vector type, it is very easy to write. A equal to, now here the A is a 2-bit value, but here I specified 1-bit value. Now how to specify the 2-bit value in a Verilog? So very simple, 2 dash, that is tick B 0 0. Now you may have doubt what is this means, right? So let me say what is this now. In Verilog, how we specify Verilog number formats? Verilog number formats, how to write? So example 2 dash, okay, 2 dash B 0 0. Example, if it is, this is the case, if I write in this case like this, see this 2 specifies which radix. This 2 specifies radix. This 2 specifies radix in the sense what? 2 specifies not radix actually, how many bit you are going to specify. The B specifies the radix actually. The B specifies the radix. See, B specifies the radix. Then this will be the given number. Now simple, I will say, I want to give the input in binary way. So I'll say how many bit you are going to give. So this 2 represents my input or output, the total size of your input or output is how many bit you are going to give. That is 2. Tick, this is the one tick, even tick actually. B, this specifies in which format you are going to give. I'm going to give the input in binary format. B. Next, what is your input? 0 0, because here I specified 2 0 0. See example, I'll say here, if I write like this 2 dash B 0 1 0, if I write like this, then this will be a wrong actually. This is correct. Why? Because here I given 3-bit number binary value, but here I specified 2 only. Then additional one more also I will say here. See, let me say like this: 2 dash. This is binary, right? D 2. Example I'm giving 2 dash D 5 3 dash D or B 1 0 1 0 4 dash H F 4 dash H 0 0 0 1 0 0 1 0 4 dash B 1 0 0 1 0, then 5 dash D 75. See example I'm showing here. This one, this see, this B specifies binary, D specifies decimal. Here I'll say B means binary format, D means D means decimal, then H means hexadecimal, O means octal. These are the number system we will specify here. We see here, now we see whether it is right or wrong. Let me say 2-D2. 2-2 means how many bit actually? Okay. D is decimal. The number 2 specifies. I can give 2 bit as 2 actually. But you see 2-D5. Decimal 5, the 2 represents the system by default. It may consider binary. 5 in the sense how many bit is required to specify 5. Decimal 5, not a 2 bit. It's required 3 bits. But I specified here how much? 2 only is specified. Then it is wrong. One which is correct then? 3-D5. If I write like this, then it is correct because the number 5 I can specify in 3-bit value. Next you do see 3-B1010. 3, okay. B is for binary. Here the binary number only is there. But here how many is there? 4 bits are there. So this is wrong. Next 4HF. So H is nothing but hexadecimal. F is nothing but 15. So 4 bit. It is very simple. So it is correct only. Now 4H0010. 0010 hexadecimal number 2. Actually, this is 2, 4 bit only. Even this also is correct. Now you can see here the length is 4, but here the length is given as 5 bit. So then this is wrong. Now 5-D75. 5-D in the sense you remember decimal 2 to the power of 5 is 32. Up to number 32 will be 5 bit. More than 32 it will go as next size. So it is 75. Then it is wrong. So these are the different number system. Octal also you can specify. Octal will be 3 bit, right? 305. Example. This is octal. 3 bit. Very, very important. How you have to specify now? First is size of your number. Tick which radix we are going to use, either binary, hexadecimal, decimal, or octal. Then the given value. You have to give this value. That is what here we written. I hope you might have understood this now. Now let me write here. If A is equal to 2-B0, it is 2-bit number, right? Next, D will be what? D will be 4 bit. So 4-B. What is the truth table? Same. Just it's a replica of truth table only. No need to worry about so much here. See, what is that? Which will be high when 0, 0. D0 is high. But you remember 3:0. 3:0 means what? It will be like this, correct? No? How it will come? D3, D2, D1, D0. This is the order actually, correct? So now which will be high? When 0, 0, which is high now, D0 is high, means this position is high. So how it will come now? It is nothing but 0, 0, 0, 1. This is the truth table. I hope you understood this. Next, what I will do, you can use if statement, else if, or if. So straight away I'll go to nested if, because more than 2-3 statements are there, then it is better to use the nested if statement. So I will use, even you can mix up all 3 also. Else.
ಸ್ಪೇಸ್ ಇಲ್ವಲ್ಲ ಇಲ್ಲ ಅಲ್ಲ ಸ್ಪೇಸ್ ಇದ್ರೆ ಸ್ಪೇಸ್ ಕೊಡ್ಬೇಕಾ ಬ್ರದರ್ ಇನ್ ಲಾಕ್ ಮಾಡೋದು ವೈಫ್ ಅನ್ನೇ ಅಲ್ಲ ಅದು ಏನ್ ಗೊತ್ತಾ ಅದು ಯಾಕೆ ಗೊತ್ತಾ ಬಂದಿರೋದು ಈ ಹ್ಯಾಂಡ್ ರೈಟಿಂಗ್ ನೋಡು ಈ ಹ್ಯಾಂಡ್ ರೈಟಿಂಗ್ ಕರೆಕ್ಟ್ ಆಗಿ ಅದು ಐಫೋನ್ ಹಂಗ್ ಬಂದು ಅಲ್ಲ ಎಲ್ಲಾನ ಆಗ್ಲಿ ಐಫೋನ್ ಅದನ್ನ ಸ್ಪೇಸ್ ಕೊಡ್ಬೇಕು ಅವನು ಹೇಳ್ದ ಬೇರೆ
ನೆಕ್ಸ್ಟ್ ಎಲ್ಸ್ ಇಫ್ A is equal to, again the input, A is equal, double equal to, you have to say. Yes, Chaya? See here, else if A double is equal to 2-P01, that is nothing but what? A is 1, means then D1 will be high. Next, A is 2, this is 2 number, right? 2, then D2 will be high. Then if these 3 statements is not true, automatically last statement will get execute, means all the 3 combinations given, the rest of the combinations what? 1, 1. So by default for 1, 1, I'll get D3 as high. Then end. This end is for this begin. See, correct no? This end is for this begin. Then always n module. This is the number system how we'll use in the Verilog format, like this only. Even 3-bit, 4-bit, 5-bit, anything you can do.